Hello, Stockholm, and hello, world. I'm coming to you in the morning in Boston. I'm in Boston, Massachusetts, in the US, and it's a beautiful day in Boston. Finally, it cooled down. It's been terribly hot recently, so today is a gorgeous day. It's a beautiful day to build a green browser extension. So I hope you're excited to join me on our little journey that we're going to take today. We're going to code this thing together, and by the end of the session, you will have deployed, hopefully, a green browser extension on either Edge or Firefox or Chrome. I haven't managed to get this thing working in Safari just because I haven't figured out how to load extensions into Safari, but if anyone figures that out, let me know. Okay. So I'll just go ahead and move to our code of conduct. So this is basically a standard code of conduct. Be aware of others, be friendly and patient, be open to all viewpoints and questions, be kind and be awesome. So I hope that we'll all have a really nice time this morning. I'm sure we will. It should be very, very fun. So welcome. So a little speaker info, my name's Jen, and I'm a cloud developer advocate lead on the Next Gen team, actually. We're a new team within cloud advocacy on the student team, and we are all about students and faculty and teaching interesting things to anyone who's interested in learning anything. So very happy to be here. I'm a Google developer expert and a cloud developer advocate lead at Microsoft. Have a lot of years of development in web and mobile development. And I love to build web and mobile apps. I haven't built a mobile app for a little while and I'm starting to miss it. So I think I'm going to have to reboot my mobile app development. Mobile apps are crazy fun. So yes, I actually have a PhD in medieval French literature. But about 20 years ago, I realized that that is not a growth industry. And so I switched to be a developer, and I've been a software engineer for many years. And now I'm at Microsoft in cloud advocacy. So it's very, very fun. I'm also the CEO and founder of Front-End Foxes Incorporated. We are an international nonprofit charity, and we promote diversity in front-end developer communities. We actually have friends in Stockholm. I wonder if Farhi is looking and say hi. We also are running a boot camp that's going to be starting a new cohort July 5th. It's an international boot camp to be learning web development skills free of charge for people who identify as women. So if you're interested in taking a look, we're at frontendfoxes.school and the registration form is open. You can always visit me online at jenlooper.com or connect via Twitter at jenlooper. Okay, so what we're going to do is build this green browser extension. The browser extension itself is not green in color. It has to do with sustainable software engineering. So I think this is such an interesting topic. And I'm coming to you live from my office. So it's so narrow, I can put my elbows on both walls, but I like to surround myself with green things, even though this plant up here has got some problems. I don't know, it's not very happy. But I think that it's a really good exercise to think a little bit about how we as software engineers can impact the world by what we build and how we build it. So we'll talk a little bit about sustainable software engineering and how we can just become a little bit more green. I'm going to just mention that within Microsoft, we have a program called Microsoft Student Ambassadors. So if you're a student and you're interested in our ambassador program, the ambassador program has 4,500 students worldwide, and they're all building and learning together. It's a great program, and in that program, there's a green league, and I am managing it. So if you're interested as a student in green things, that's a terrific program to hop into and to join us as we talk about all things sustainable. So let's talk about building this extension. What we're going to do today is learn about sustainable software development, and we're going to code together. So there's a couple links, I believe, in the chat that you can take a look at, and you can get prepared to code together. So as you're getting ready, you're going to want a GitHub account, Visual Studio Code, a browser, which I'm sure you have open now, and any kind of internet connectivity. You're going to need Node and Npm. So if you're a JavaScript developer, you're probably all set up for this. But if there's a couple downloads you might want to do, you might want to just grab Node and Npm, because we're going to do an Npm build, Node Package Manager build, to get this browser extension built, and then we're going to load it up into Edge. You can also try loading it in Chrome or Firefox, like I said. Okay, so let's go ahead and start by talking about Sustainable software development. What on earth is sustainable software development? Well, it's an emerging discipline at the intersection of climate science, software practices and architecture, electricity markets, hardware and data center design. Hardware is the real crux of sustainable engineering. And there's a very interesting website that my colleague Asim put together called principles.green. I'd love for you to take a look, just visit it. Microsoft also recently launched a green software foundation. So we are really trying our best to become carbon neutral, and I believe there's a water saving program that's starting as well. So really trying to lessen our impact. We're a huge company, and we're trying to lessen our impact on nature as we progress. So take a look at Principles Green. Come on, there we go. So the goals of these principles, and as someone who's interested in becoming a sustainable software engineer, it's interesting to think of a sustainable software engineer as someone who follows these recommendations to be empowered to make decisions that have a meaningful impact on the carbon impact of their applications. So with that in mind, let's just take a look at these 8 recommendations. These are the 8 principles of sustainable software engineering. Let's just walk through them. The first one is to build applications that are carbon efficient. Second, you want to build applications that are energy efficient. You want to consume electricity with the lowest carbon intensity. Keep that one in mind because we're gonna build around this one. You want to build applications that can run on older hardware so that you don't have to constantly be building newer and newer data centers. You want to have some kind of backwards compatibility. You want to run servers at a high rate of utilization. So you don't want a server to have to boot all the way up and then just use a little bit of it. You want to use as much of its power as possible, so that you can configure your servers to do that, and you can configure your application design to help your servers run at that high rate of utilization. You want to reduce the amount of data and the distance it must travel across the network. So in the cloud, when we're developing on Azure, for example, we use our closest data center so that we are having data not be traveling all the way from Boston to Redmond. I would use a data center closer to me on the East Coast somewhere. In Europe, you want to use the European data centers instead of all the way back and forth. Number 7, instead of shaping supply to meet demand, try shaping demand to match supply. That's an interesting one. Let's put some thought around that. And then number 8, focus on these end-to-end optimizations that increase overall carbon efficiency. Can you think about whether your application could run offline? Whether you could do an optimization that would allow your iPhone application to run on older versions of the software so that people wouldn't be forced to upgrade to use your application. So there are these interesting little things that you can think about as you're developing your software that will just help match and meet these 8 principles. So let's think about how we would go about building a carbon-friendly app. What architecture decisions would you make? Should we build a website? Greenfield, a nice website? How about a mobile app? What about a desktop app? Something that runs, just within someone's desktop and could maybe even run offline. So the problem is that, if you're building fresh web applications and web assets that are always online, you're really consuming unnecessary energy to keep them alive, keep them always live. There is a solution, which is cloud hosting, and that can help spin up your websites and your assets when they're requested and needed. Another solution is an offline first strategy that can help you keep your energy requests low. So that's kind of interesting. You have the strategies of caching and strategies of using local storage to bring data that doesn't need to be refreshed all the time back into your application so that people can only request for a refresh when they really need it. Like if I'm trying to book a hotel, I can specifically go to a place where I grab my information that I need for today. But I don't need to grab that fresh information every time I go to look at a hotel website, that kind of thing. So there's some interesting strategies that you can think about as you're building your web apps to make them a little bit more sustainable. So let's think about building something that's hosted locally. It's going to be able to answer several of the principles I talked over. Let's think about building a browser extension. So I wonder if everybody could pop into the chat and just tell me whether you've built a browser extension before. Before I started this project, I never had, and now I'm kind of hooked because they're really fun to build. And you can build little tools for yourself, and you don't even have to deploy them if you don't think anyone would be interested in them. But there are some really fun little applications you can just build for yourself and then just deploy them on your own browser so that you have them for yourself. One of the ones I want to build, I haven't gotten around to doing it, is that I want to build a dieting application because I put on some extra pounds during pandemic, and there's a couple diet programs that have a color-coded regimen that you can follow. And they have these little boxes that you can eat a little of the red box and a little of the blue box and a little of the green box each day. And there's a little chart that you could click on maybe, and this would be a great browser extension. You could say, okay, yes, I ate all of the red foods for today, so no more for me. This sort of thing. And then it can like give you a little checkbox at the end, like you ate properly today, that kind of thing. I don't know. I want to build this. Let me know if you are interested in a collab. But I think we can go ahead and build something a little greener than a diet app, although your diet, of course, impacts nature, of course. But what we're going to do is we're going to build this local browser extension. It's going to be carbon efficient and energy efficient. It's going to reduce the amount of data and the distance it must travel across the network, because what it's going to do is it's only going to grab that data from an API ad hoc. So it's going to sit in my browser quietly until I open it up and refresh it. So it's going to help me make decisions about when is a good time to use energy according to my region's energy usage and the place where that energy is coming from, the origin of that energy, the origin of that electricity. So this is this idea of building an application to tell you about the carbon intensity of your region. And it'll just show you where it's at so that you can make decisions. For example, this application would be a great thing to have in your browser, and you can just click it whenever you want to run an errand in your car, or if you want to run your dryer. So it turns out that running your clothes dryer is a very intense thing to do, especially if you have a gas dryer, which a lot of us have. So what you could do is you go to your browser extension and click it and get a little reading of your region's carbon intensity. And if you're in the green, that would be a great time to run your dryer. If you're in a very carbon intense moment, energy intense moment, that might be a time to wait and just not run your dryer. So this is kind of this very simple application that we're going to build. Or you could get a clothesline and avoid the whole situation, but that's a different problem. Okay, so this green browser extension is going to help you make educated decisions to manage your personal energy choices. It's going to be hosted locally. It's going to be called ad hoc, and we're going to build it with vanilla JavaScript. So there's very little overhead. It's a very small little extension. All it does is calls an API, ad hoc. So I just want to call out the fact that not all browser extensions are created equal. My colleague sent me a reading of his extension on Edge that is really pretty, it's big, it's I think 31 megs, it's hard to see, but it uses a lot of his CPU, actually. So I think what this was 1Password, if I'm right, extension, oh sorry, LastPass. So these password extensions are pretty heavy duty, because what they have to do is they have to be, querying and checking for different passwords on different sites and where they're stored and all of this sort of things, and it has to be kept up to date and run in the background. So that's what we're not going to build. We're not going to do anything that runs in the background. I just wanted to mention that some browser extensions, percolate in the background and actually consume quite a lot of energy. So good to know. Again, we're talking about architecture decisions. So I like to think about the greenest app as the one that you don't build. So instead of building a big website or a mobile app that will be sending you push notifications when you need to do your laundry, which would be very annoying, actually, we're going to just build a little tiny browser extension. It's your personal carbon trigger, and it gives you your region according to this API, and it'll tell you the carbon usage in your in your region. So in this example, we have a reading of the grams of carbon emitted per kilowatt hour. And it also gives you a reading of the fossil fuel percentage. So that's interesting because you want to kind of know where the energy is derived from. If you're in a region that uses a lot of wind or any kind of renewable energy, that's going to give you a better reading. This is like quite a lot of fossil fuel in my being used in my region. That's a little disappointing. So let me just show you what this browser extension looks like in Edge. So right now, I have this, let's see, I have it loaded up. And this is the home page that we're going to create. So I'm going to give you my region name. It's USNEISO. And my API key, I have to just grab this because I copied it from Carbon Trigger. Just going to grab this and pop it in. Let's see if I have the right region name. Oh, sorry. My bad. This is my mistake. I loaded the extension from the unbuilt code that we're going to be working on, so it's not going to show you what's going on. Let me see if I can have this running in Chrome, if it's running properly. No, okay. Well, I'll give you the demo once we get the thing built. So because I'm loading an unpacked browser extension, and it's not built yet, it's not going to show us exactly what's happening. But basically, you have this little dot that's going to change color according to your region name and your API key from this website called Tomorrow, and just give you your carbon intensity. So let me show you this electricity map, and this is where we're deriving the data. So let's just check. I'm here. I'm in this kind of New England, relatively carbon intense. You can tell I've only 24. Here, let me move this over. Only 24%. I'm in this little hook right here. Only 24% of the energy right now is renewable, so that gives me a pretty not great reading. It's a pretty carbon intense region. It's even worse down here. What's going on down here? Let's just check Stockholm. I'll bet you you're doing better than we are. Let's just see. No, Sweden. Okay. Yes, see, bravo, Sweden. You're getting a very nice reading. Look how much renewable energy is going on in these areas, right? So look at this, a very beautiful, actually. You're gonna have a beautiful green browser extension if you're located in Sweden and watching this. Interesting, look at the Poland. I think there's quite a lot of coal mining in Poland, but it's very interesting to look at this energy map. So if you go to electricitymap.org and take a look at your zone is going to be -SE for Sweden. So that's very nice to know. So we'll go back to North America where, oh boy, good fun. Okay, this is actually a very beautiful map, actually. It's done in, I think it's a D3 map. Okay, so let's go back and see what we're going to do. So that's what we're going to build. We're going to build this green browser extension. We're going to use the C02Signal API, which is this electricity map. That's where the data is derived from. The color of your icon is going to change based on the carbon intensity in your region so that you can get this quick readout of your region's carbon status. And I like to say knowledge is power, right? And knowledge saves power. That's a pun. So let's go ahead and get building. So that was the demo, although it's not going to work just yet because we haven't built the thing. So what we're going to do now is we're going to start working together. So what you can do is go ahead and clone this repo, and it is GitHub JLooper carbon-trigger-extension. It looks like this right here, carbon trigger extension. And you can go ahead and log into GitHub and just click fork. You can fork this. I'm going to refresh this and see who's forking it. Come on, come on, come on. Got to get past 41, 42. Good job. Okay. I'm surveilling you, you see. Okay, so go ahead and fork this. And then I want you to switch to the start branch right here. So the way I do that is I go ahead and open and just clone this repo. Sometimes I use GitHub Desktop, and with GitHub Desktop, you can open it in VS Code automatically. So that's very helpful. So I always work in Visual Studio Code. Let's see how many forks we've got. Any more forks? Come on. 43, all right. I can tell you're working. Good job. Okay, so switch to the start branch, and I'll go back to, oh, by the way, this is the principles of software engineering. I'll close that. We're going to go back to our code. So I'm going to go ahead and rearrange my screen a little bit so that we can see what we're doing. And once you have this code base, go to the start branch, navigate to the root, and type npm install to get your dependencies installed. Then I would like you to go ahead and start exploring the files. So I have Visual Studio Code open here. I'm on the start branch, you can see right here. And you're going to notice that it's basically unfinished code. So the main work that you're going to do is in this source folder. It's just a little index JavaScript file. There are some form fields and results saved here. This is vanilla JavaScript, so we're not using any framework. So we have to do some DOM manipulation. We use document.querySelector to grab that form data. This is where you're entering the form. There's a place to load up any errors, that little loading thing that we saw. And then there's a results container. That's going to contain our readings for our carbon usage. And then there's going to be a clear button. And then there's some functions. We calculate the color of our little dot at the top. And I actually borrowed this idea and some of the code from Energy Lollipop, which is a really cool browser extension built just for California. But you can take a look at that one too. That's really nice. This whole project is a fork of another developer's starter code base, actually. So all of that is documented in the repo. I like to give credit where credit is due because it's a very nice repo. Okay, so here's another. So we have calculate the color, we have display carbon usage, and then we are going to set up our user, handle the form submission, and then there's this init. So once you see init, you're going to start looking for these little leaves, right? These are little comments. So we're going to follow the bouncing sprouts and fill in the code base. So at line 78 on your start branch, you see the first little sprout. So we're going to start storing our keys in local storage. Okay, before we start typing, let's just explore the files. So we have looked at source, that's your JavaScript code. In the dist folder, you can see the manifest. And this gives you some information. It's called my carbon trigger, we're at the version. It's looking at background.js as a loader script. In dist also we have index.html, and that is your front end markup. So welcome to your personal carbon trigger, and here's your little form, here's your submit, and then here's that second div where you're loading your results. What else to show you? Dist background.js. So this is this background file that runs in the background. I don't know why it's flagged as a React, but it's not. And this is where a little background process is watching for any updates once we ask the API for an update of the carbon intensity. And we're going to go ahead and complete this code so that the color of the icon will change when we call this draw icon function. And then I guess we also walk through index.js. Actually, that's not dist. It should be main.js. Sorry, that's a typo. This is what is built. In the dist folder, you have main.js, and this is all the built code. So you don't edit this. This is all going to be built when you type npm run build. Okay, so let's close dist for now and go back to source index. Line 78, let's start. If anything is in local storage, pick it up. Okay. Oh, so before we start typing, sorry about that, one more thing. Here's how to load a browser extension in Edge, and Chrome is very similar, so is Firefox. You build a copy of your extension, and then you go to this tab with the little dots to extensions, and you're going to load an unpacked extension. That's what just happened, and you saw the demo kind of fail because it was trying to load this unpacked extension, and the thing isn't built yet. So you can always click reload once it's loaded up and built. So I'm going to go ahead and do that. Okay, so that's how you load these extensions locally. Okay. Also, before we start typing, sorry, I keep getting ahead of myself. Go ahead, we looked at the energy map, but you're going to need an API key. So go to C02Signal.com, and you're going to request an API key, and it will be emailed to you really quickly. So you can just grab that and save it somewhere on your computer, just in a text file or something, so that you'll know to log in. That key is going to be stored in your local storage, in your browser extension's local storage, which is a trick. And then you need to find your zone. We found it for Sweden, it's SE. For me, I have a couple that I can try, US NEISO, and there's another one that you can try. Okay, so those are the three things you need. You need to get an idea of what you're going to be looking at, get your API key, and find your zone. Okay. Finally, we can start typing. Okay, so what we're going to do is in source index on line 78, we're going to add a check to the init function to see if there's any API key or if the region is set in local storage. So I'll go ahead and just add a line here. And I have an extremely clicky keyboard and issues with multitasking. So I'm going to go ahead and just copy and paste this in. I hope you don't mind. So we're going to go ahead and grab the stored API key and the stored region if it exists. Okay, and that's all going to be stored in local storage once you fill in your form. By the way, if you get lost, you can always just move from your start branch to the main branch where all the code is completed. Okay, so the next thing we need to do is manage our local storage inputs. So we're going to look at the setup user method, and we're going to set the user entered API key and the region. Here's where we're setting that key in local storage. So the API key and the region name. So let's go ahead and look for number 2 here. Add a line. Grab this. Pop it in. So down here we did a get item in local storage, but here's where we set item, because in the setup user area we have to set the item with the API key and set the item region name, and that's all user entry. The next thing we have to do is we have to make the initial call. So once the user inputs are all set up using that setup user, we have to make an API call to get that region's carbon intensity. So we're going to go ahead and look for number 3, display carbon usage. It's right here, make the initial call. It's going to be display carbon usage, which is this. Like that, let me save. Okay, make the initial call to display carbon usage by passing through the API key and the region name that you just grabbed. If you look for display carbon usage, that's up here on line 32. So you're passing through the API key and the region, making the call, and then you're gonna, with your own token, you're gonna start getting some information. So we're gonna work in that function right here, display carbon usage for number 4. So the fourth thing we have to do is we have to display the usage in the carbon source. So if I were you, I would flip to the main branch briefly, copy this code and paste it in because it's quite a lot of stuff to type. So we're going to go ahead and do a couple of transformations. We're going to do a little math to get the carbon intensity and display it as grams, which is grams of CO2 emitted per kilowatt hour, which you saw in that screenshot. And then we're also going to show where the percentage of fossil fuels used to generate the electricity. So let me just pop that in here. Number 4. Looks like that. Okay. Great. This is going fast, I know. I tried to reduce the amount of typing, but you do have the built code in main. Number 5 of 8 tasks. The next thing you have to do is set the icon to be a generic green color. So before you load your API key and before you have information about the carbon intensity of your region, the color is just going to be green. You can change this to any color. You can make it pink, it doesn't matter, but we're going to just give it a default. So let's see. And this is, by the way, using the Chrome runtime which is Chrome runtime send message. So Chrome has, in its runtime, has little ways to send messages back and forth in the background. Remember that background JS file? And Edge uses the Chromium runtime. So that's very helpful, so that we can, have these browser extensions working on all of these systems. So let me go ahead and grab number 5. All right, and we're going to look for area number 5 right here. That's in the init function. That's on line 90 for me right now. So here's where you set your icon. I mean, it's setting a default, so obviously it's going to go in the init area. Okay. I hope no one's teasing me in the comments about using a white light mode. I actually find it a lot easier to look at. But I made my slides dark mode, so we're very diplomatic here. Okay, so in init, we set the icon to be a nice green color. That's going to change. So here we're going to calculate the color of the icon based on the carbon intensity number that comes back from the API call. So here we're going to go ahead and set the CO2 as a number and then run the calculate color, which takes that number and feeds it into that calculate color function. So let's look for number 6. I just saw it up here somewhere. Right here. So let's walk through this. This is in the display carbon usage function. Remember, this is where we're calling the C02Signal API, giving it the region, giving it the API key in the header, and then when the response comes back, this is an asynchronous call. Wait for the response, and when it comes back, you're going to calculate the color of the icon based on the carbon intensity. So let's grab that code here. Again, always you can have that, the completed code is on main. So let's see. Yes, nice linting. So here we're going to have the CO2 be a little calculation according to what the response is. The response comes in as data carbon intensity. Send that value to the calculate color function, which is right up here, another asynchronous call. So this is the CO2 scale that I just kind of hard coded it as a general idea of the colors that come back. You could take a look at this and make it more sophisticated if you wanted to. Maybe change the colors a little bit to your liking. I just hard coded 0 is going to be this color, which is probably a green, is it? I don't know. And then it gets progressively more and more orange, yellow, orange, and red. So by the time you hit 800 as your carbon intensity, your little dot's going to be quite red. But what we have to do is update the icon here in the calculate color function. So right here, we're going to tell Chrome, we're going to give Chrome's runtime a message saying, please update the icon to this color, which is called closest color. So let's just add that in here. The 7th bouncing sprout. Okay. So watch the syntax on this. There's a parenthesis, a curly brace, and then another curly brace here. So make sure that's closed and closed. So pass the runtime this message. And the last thing we have to do is do something with that message. So here's where we jump into the dist folder, which is this kind of listener function called background.js. And number 8, you see the bouncing sprout, you're going to set the icon. And what's happening here is you have a listener set, and it's listening for something called update icon. Remember we said, okay, the action is going to be update icon, and the value is going to be closest color. So in background.js, it's listening for something called update icon to be called. It's like, oh, I hear you. I'm going to go ahead now and redraw the icon. And it's using the Canvas API. Let me just set this in here. So we're going to set the icon by calling the draw icon function, which is right underneath. Okay, so remember we're grabbing the message that was sent through, we're grabbing the value of that message and sending it through to draw icon. Image data draw icon. Okay, so draw icon is right here, and you can see what's going on here. We're manipulating the Canvas API. If anyone is interested in animations, a lot of people get started by tinkering around with a Canvas API, which allows you to draw in a browser. You can do it 2D or 3D, and what it does is it draws shapes. So here we're beginning, we're saying context in a 2D context on a canvas. We're going to begin a path. We're going to fill it with this color that we're passing through. And it's an arc, and we set it to be basically a circle, and then we're going to fill it. And then we're going to return the whole image. So that's what's drawing the little icon at the top of your browser. So we have completed our code. I hope some of you have successfully copied and pasted all of that stuff or typed it in, which is a challenge, but I hope at least I explained it a little bit so that if you come to it later, you can have some success building this. But what you want to do now is go to your Carbon trigger, navigate to root, let me just go here, and type npm run build. And what it's going to do is it's going to use Webpack, hopefully, if all goes well. Yep, and it went ahead and built that index.js. It rebuilt index.js as a file. So what's mode to do Webpack? Okay, yeah, this is a Webpack issue, so it's not a problem. We're in basically development, so it's not impacting us. But it went ahead and built. That's very good news, because what we can do now, cross your fingers, in the extensions panel, we should be able to go into Edge and go to extensions. My Carbon trigger is already loaded up. I'm going to reload it. It set it back to nothing, as if I never touched it. So here we are, and it grabbed out of my local storage the information that I had stored previously because I was tinkering around. I set a little bit different region for myself, USNE, ISNE. So that's another region for my area that I can try. What's going on here? So a lot of fossil fuel. So it's giving me this kind of red icon. Not brilliant. You can see how it just flashes green because it resets and then it calls the API. So you can see that that's an API call right there. These extensions come with their own browser tools. If you get confused, you can always inspect your browser extension, and you can see what's going on with any network calls. It's kind of hard to see because it closes. That's not very helpful. But anyway, watch out as you're developing browser extensions that use local storage, because they use their own local storage, not the browser's local storage. So it's like a tiny application within your browser that's running a little bit independently. So that's a little bit of a trick. And just so you can always watch your local storage. So if I would go to application, local storage, you can see I have set some, it's kind of hard to see. Yeah, so there's my API key, and here's my region name set in local storage. So go ahead and you can inspect your browser extension and make sure that your local storage has been set the way you're expecting it. I'm curious what's going to happen if I click change region and I put in Sweden. And let me just check my API key again. I'm just curious what color it's going to come back with, because I'm not thrilled with my color choices. I think this can be improved, but you're definitely doing better than I am. I think, remember we were talking about how I hard coded those colors? I think this is a bit of code that could be improved. So I'm happy to take your pull requests on this one. But basically, you have a less intense region, carbon speaking, than my area. Take a look at your fossil fuel percentage compared to mine. That's very nice, right? And we saw that on the electricity map. But yeah, so that is what's going on here. And it's going to just stay this way until I click it again to recheck. So if I'm thinking, I want to string a whole bunch of Christmas lights outside and I want them to be turned on at certain times, maybe I would go ahead and check my browser extension to see when would be a good time to turn those things on and off, that kind of thing. So just consult your ad hoc browser extension that you have built for yourself. So after all of that, I think we got through everything we wanted to get through. The browser extension is loaded, it's working nicely. I just want you to remember that the greenest web asset is the slimmest one, the one with the least overhead, and the one that's only really called ad hoc, right? Whenever you need it, not all the time pinging in the background. And you built something really slim. It's basically two files that you're building with, and by the time you've built your browser extension, you have an index file and a JavaScript file, and that's it. You built something really slim that helps you make greener decisions, and I hope that you learned something today. So I just want to thank you for coming to this talk and building with me. And you can always follow me at Jen Looper. You can go to jenlooper.com. And I would love for PRs around those colors. I'm still not satisfied with those, so let me know what you think. And we have a little survey at the end. The event code is 13370. Love to have your reactions, since it is the reactor after all. Very punny today. So I'm going to go ahead and Iman, should I stop sharing my screen and take some questions? I'll stop sharing my screen anyway. Is there any, so Omar, I'm pretty sure that they will have a recording of this. Iman, do you want to talk about, okay, the Reactor YouTube channel. Awesome. Anyone else have questions? I know it's a lot of, code to tinker around with. Hopefully everybody saw eventually what I was doing. Yeah, good extensions. Yeah, cool. What else would you like to build in terms of green browser extensions or any kind of a browser extension? Somebody want to help me build my diet extension? Happy to take any questions or go back over any code or talk about any other things you want to talk about. Last time I was in Stockholm, I saw the kids. How do you set up region code? Okay, so what you do is you go to the this website. Let's see, it's electricitymap.org. That's right, I did not really explain that, did I? Here is the electricitymap.org, and you can zoom around and click on your extensions. So Sweden is SE, and you can just click on your area of the map and look in the browser. So it says zone-Sweden, SE, like that. But there's also a place in this website where you can grab your actual zone. If I could find it, I would give it to you. Get our data. Anyway, that's the easiest way. So if I would click on France, it would say zone/FR. That's probably the easiest way. So you can just feed that into your extension, zone/GB. This is built by Tomorrow, which is a really cool startup, and they just released a very nice weather app that you can download and get really interesting information about your weather. I just downloaded it last night. Nice application. Yeah, anything else I can help with? Anyone working to become more sustainable at work? Is the extension laggy for anyone? It'll depend on how fast your internet is when you grab your API, when you query the API. So hopefully it will be somewhat speedy if your internet connection is speedy at that moment. But let me know if you're having issues. Harith, I can see you're typing, so I'm waiting for your question. Does the API work for all regions? Yeah, no, it's only the ones available on Electricity Map because that's their API. Is there a particular region that you're looking for? I think there's a way to request that your region be added. Let's see if there's get our data. Global coverage, worldwide coverage, standardized across regions, imports and exports across regions. I mean, it's relatively detailed and complete. However, if you noticed, bless you, the North America map is pretty spotty, actually. I was actually surprised this morning looking at that. And I think what happens is that they are querying certain data centers, and sometimes they're not getting information back. So like the entire west coast of the US says live data temporarily unavailable. That's interesting. So I don't know what's going on in California, but nothing good. At least the East Coast, thankfully, the East Coast is coming back for me. But yeah, so maybe Luce, if you're looking for a region that doesn't exist yet or is not getting data back, that might be where your lag is coming from, actually. Maybe you can tell me what region you're looking for, because like look at all of Africa except Nigeria is blank right now. Most of the Middle East, like, boy, Australia is not very eco-friendly down there. Okay, yes, so question. Oh, the lag is coming from the text boxes where you enter region and API key. You might want to look at your inspect your application and make sure there's no errors, because I wonder if there might be a mistake in the code, or switch over to the main branch, rebuild, and reload the browser extension. That'll give you a faster response. What other practices do you suggest for a more eco-friendly way of developing code? So this is something that we're kind of struggling with and trying to find ways. I think there's many ways you can make your code more eco-friendly. I think trying to make as many parts of your code offline friendly is a great idea. I also think that avoiding things like, it used to be fashionable to have videos running in the background of your web pages. Remember that style of web design? Nobody needs that. It's not even very, inclusive. Like, let's design simply and use, if you're using JavaScript frameworks, use lightweight ones. You can avoid heavy applications by doing tree shaking. Angular, I remember, had a lot of tree shaking built in. Vue is very good about it. I'm sure React is as well. And then there are some interesting projects that we're working on with some student ambassadors in Visual Studio Code to figure out the electrical usage of Visual Studio Code as you're developing an application. So we had a little running tally of how many API calls are going on in the background, how intense your programming is. We were trying to verify that we were doing this all properly. Software engineering, to make sustainable software engineering, is a little more difficult than to make sustainable hardware engineering, it seems to me. Like, there are very clear things you can do to make your hardware a little bit more green. Software engineering is a little bit more subtle, I think. But there are small things that I think you can do. So those are a couple of them. I hope I answered that question and didn't go off on a tangent. Any other questions I can help with? Yeah, and check out this software foundation. I'll give you the link. It just launched, so it's the Green Software Foundation. Let me get the link. Green Software Foundation. greensoftware.foundation. Cool. There's a newsletter that might be nice to join. So this is also Asim's and his team's work. So this is nice because it's a partnership of Accenture, GitHub, Microsoft, and ThoughtWorks, and it has these kind of a nice board where people are joining. And interestingly, you can join this foundation as an individual contributor. potentially. So join the newsletter, get some information about that. Maybe your organization could join this foundation, and that would give you some structure and some frameworks around building sustainably and creating green software. So I think that's quite an interesting opportunity to try. Yeah. Any other questions? Ayman, we can probably wrap up pretty soon. Did anyone build the browser successfully? I hope that the lag situation solved itself. You can reach out to me on LinkedIn and I can help you debug. What's in store for the next time around? Ayman, you probably know this more than me. Oh, how to get region name? Tell me your region and I'll get you your code. So basically what you do is you go to the electricity map. Yep, there's that one too. So you look at that zones listing, but if you zoom around on this map, alternatively, zoom around on the map, find your country and click on it. And in the browser, you can see zone/FR because I just clicked on France. It's just that you're out of luck if you're in the Western US right now, or a large chunk of Canada, and China's not coming through. Siberia's coming through. Got it? Okay, great. Cool. I think we're all set. So thank you very much for joining us. And yeah, take a look. Yeah.
Right as soon as you wrap up, are you able to share that survey link slide as well?
Sure.
Perfect. So for those of you in the chat, I'll add the links to the series pages for the higher ed series and the green tech series. We have events almost every single week. So I'll just add what the next one coming up is if you're interested. Jen, I believe you're actually running this exact session again and doing another green browser session. So I'll add that link in the chat as well. But if you all could please fill out this survey, it lets us know what you think about workshops like these and what you would like to change. And yeah, it just helps us out for future sessions. So thank you so much.
And Ayman, I think the next group of this series is all about green software, right?
Yes, I believe so. I'm just going to confirm exactly which one and when.
There's a whole bunch of them coming up. I think Asim's going to be speaking.
Yes.
Yeah, it's going to be quite good. So if you're interested at all in this stuff, listen to Asim. Don't listen to me. He's the authority.